So today we're going to learn about density, right? And each liquid weighs differently. How many of you think liquids weigh differently? How many of you think so? What's up, Elijah?
Actually, there's a project on this.
Well, that's what we're going to do now, dude. Don't spoil it. So, don't worry. So this is what we're going to do first. We are going to, actually, let's see, who's the helpers? Let's see, I know Colin's one of them, right? Colin and Nathan. All right. All right. And I think my TAs. Who are my TAs? Okay, Orion?
And Estrella.
Yep, Estrella and Carly. Aren't you another helper? Yep, you're TA. Okay. So right now, don't worry about these. We will pass these out in a second. Make sure everybody gets one of these and everybody gets one of these. Okay? We're going to do a little bit of reading, guys, before we get started. We're going to read this together and we'll get this all squared away. It seems like a lot, guys. It is not that bad. We're going to go over this together. We're not going to pass that stuff out yet, guys. Because I already know if you guys get the jars and the oil, you guys will be messing around with it. Okay, does everybody have the reading? Everybody have this page? Who's got the book? Everybody got the booklet? Okay. Can I have a volunteer to read the first paragraph? Bentley's hand was up first. It's all right. Yep, the first paragraph.
Lava lamps are loved all around the world. These lamps were created in 1960 by Edward Craven Walker. He created them to create a mood of
Relaxation. It's okay.
Instead of as a lamp, these lamps are looked at in the dark as you watch the wax rise and sing.
So yes, we are going to make lava lamps.
Are all of us?
Yeah, all of you guys are going to get, each table's going to get a jar and we're going to see what happens. Okay?
Keep them in plastic.
We probably can. We'll take a look. We'll see if we have room, you know. So, next paragraph. Who wants to read the next paragraph for me? Carly! It's all right.
How do lava lamps work? Lava lamps are all about destiny. Is
Density. It's okay.
Much fits into a certain place. For
Instance.
a core
Good.
has a lot of air packed into its space.
Good.
This means it has less density than a rock that is packed tightly with solids. A lava lamp, the wax is more
Dense.
dense than the water. What actually changes the density of the wax is the heat caused by the light bulb underneath.
So we're already seeing, what are we seeing from that? Density changes, right? So like whether it's the lava lamp, heats up that wax, it gets thinner, that's how it moves. Kind of like the opposite, right, with water, right? What happens when you freeze water?
It stays
It becomes ice, right? When you warm it up, it becomes...
water.
No. When you warm it up, what does it become?
Steam.
Steam. Good. That's what it does. Okay. Nathan's been bugging me. We still have one more. Nathan, go ahead and read.
Temperature changes density when wax heats up. It begins to take in the heat. This causes the mass to expand. The hotter it gets, the less dense it becomes. As it gets hotter, it starts to rise above the water. Because the wax is less dense than water. As the wax rises, it moves away from the heart, the heat
Good.
starts to cool. As was taking in heat and
Dissipating.
dissipating, spreading it out. It is a slow process.
Right. Okay. So like when you guys turn on a lava lamp, it doesn't like instantly do it.
Yeah.
Okay. Now, let him mind because she's been the whole time she had her hand up like when we were eating. I'm like, oh, you can put that down, but it's all right. Maya, go ahead and finish it off, guys, and then we're gonna do this together.
When creating a lava lamp at home or store, it is created a bit differently for safety reasons. Light bulbs can get very hot and can be dangerous. Instead, these lava lamps are created using oil and water. Oil is less dense than water, so it rises above it. The alpha
Salsa.
sulfur
Tap.
catalysts
Good.
are used instead of light bulbs to move the liquids in the beginner or releasing carbon dioxide
Good.
type of gas. This actually causes the water, not the oil, to become less dense. Once the gas leaves the container, the liquid settles back down.
Perfect. So the answers are kind of right there, right? So we're kind of going to see what happens. But first, we're going to fill this out together, okay? It's not that bad. So go ahead and get a pencil, pen, color pencil, whatever you guys want to use. I will let you guys use color pencils to fill this out. Tell you the truth, color pencils may be better because I have to show examples and you guys can read it.
Well, I don't have any.
It doesn't matter. Either or. I'm just saying if you want to. You can use a regular pencil. Gently.
So color pencils, did you say markers or color pencils? I don't think you said markers, Santiago. Just pencils.
If we have time, we'll see. But you guys are probably going to be so fascinated with these lava lamps, you guys are going to ask me to put like 5 Alka-Seltzer tablets in it.
Hurry guys, hurry fellas.
Hurry.
We don't need this big color. I'll pick one for you.
Carly.
Wait, I need black.
Nope, go sit down. Sit down.
Come on, guys. Let's go. The faster we get this done together, the faster we get started. Okay. Go ahead and go. Let's go to the first question. Now, I don't expect a paragraph, but I do expect a sentence, guys. You guys are 5th graders, you know. So go ahead and work ahead if you want to. But the first question is, we are not using heat to create the lava lamp. Predict. Predict means you're just thinking what's going to happen. What you think is going to happen with these materials? Now, we're not going to go over every single question because some of these are after the fact that we do it. We'll come back, but let's do the first question. So we're predicting, right? In science term, what does that mean? Starts with the H.
Hypothesis?
Good, Anthony. Then once you guys are done with the first question, we will go to the next page because the next 3 questions are about what the experiment, what happened. Okay? There's a couple more minutes. Who still needs more time to finish the first question? Anybody? Okay. So turn to the next page, the vocabulary, guys. So next page on vocabulary, these are the words that we read in the article. If you guys need to go back and look at the article for the answers, go ahead. But go ahead and answer those 5 questions for me. If you need help with any of it, just let us know. ones are actually open. Like this one's not.
So we're supposed to density, expand, dissipate, temperature, carbon dioxide. So one says by increasing the blank, it becomes less dense. Is it increasing the dissipates? Is it the expand, increasing the expand? Increasing the density? I don't know if that's gonna make sense, this is dense here, right? What about temperature, by increasing the temperature? Or what about carbon dioxide? The process of elimination, what was
Then if you guys finish the vocab early, go ahead and go to the next page. Take your time. This next page, we literally, we're calling this thing now. It's just saying add these in your own words. Like the first question is, in your own words, what is density? How does the lava lamp work? What effects does density have according to the reading? Okay, so this is your own words, guys. I don't expect like scholar, PhD work.
I do though.
Yeah, Mr. Hodges will. It's all right. Keep going. As Mr. Reese struggles to open up a food coloring. Now for the food coloring, guys, we'll have different colors, okay, but don't expect to go crazy.
Are you gonna use the document?
No. No. And then the last page, guys, if you guys are done with that page, some of you are working ahead, you're just gonna draw what you think is going to happen.
I already know what's gonna happen.
Well, draw it.
Well, what
So you gotta draw it.
affects density? What affects density according to your reading? So you may
Okay,
have to
next
go
page you
back-
gotta draw it.
You may have to go back to that and refer back to our reading, right? So what affects density according to your reading? So the top portion is everybody. Good. Read the sheet titled Lava Lamp Density, and then answer the following questions.
Draw what you think is gonna happen with these jars.
Be sure to support your answers.
So what do you think is gonna happen with
What
these little
is
mason
density?
jars?
What density to use?
Add all that together. Okay. So I don't draw a lava lamp, guys. Draw like with this. What is gonna happen with in here? If you drew a lava lamp, don't worry about it. I'm not gonna make you redo it, okay, Colin?
I'm gonna go back to one of them after this so I can make it.
Let's read it. I see here, lava lamps are, let's read this here. Lava lamps are all about density. Density is how much fits into that space. For instance, a fork has a
What
lot
we're
of
gonna do with those long lamp once we're done
This
with them?
means it has less density than a rock.
It doesn't have to be vegetable oil. We'll go after the fact. We'll go more into it, okay?
Go ahead, keep going.
Yeah. So that one, bud, is literally just putting in your own words.
How much
Okay?
fits into a certain space. So if this book has,
Doesn't it, I don't expect you to draw all the lines, okay? Just a sentence.
do you think there'd be more density that has, say, 1,000 pages? So what would be density in your own words?
It's all right. If he's already done it, he's already done it. I. Okay, Colin.
What do you mean
So how much, so how would you put in
Yeah, it's fine.
density, in other words, how much fits in space?
What's up, buddy?
and
No, I'm not gonna, because it's pretty much asking the same thing that you guys already did in your own words. Okay?
Density is how much fits in space. So could you rephrase that in your own words? Density is. Okay. Give you an example without too many cats, too many cats of,
Just go ahead and help your team.
I'll do it. It's good to go, because the city of Team Project wants this.
so you could use your own words.
Actually, can you go to the classroom next door and grab me one more jar? It should be right by my desk, okay?
So I can show it on.
Can I finish the level or can I, pretend completely done? Like coloring it in?
Yeah, you can color it in. That's fine.
Yeah, if you guys are done early, you guys are, some people are still working, you guys can color it.
How does the level work? When something blank.
I think I sent him in there to get a jar.
Red texture.
I sent him in there to get a jar.
So you got 3 words, so we even started getting that one. When something density is.
I was like, it's right there by my desk.
When something expands, it's spreading out or scattering. When something dissipates, it's spreading out or scattering. Which word sounds like? Yeah, it is spreading out. Okay. You think dissipates or scatter? Okay. Alright. You're correct.
If you want, go ahead and give every table a jar. Okay.
So if this is dissipates, then we only have expand and
Each group one jar.
and density, right? So it says, if it expands, it is getting larger. If it's density, it is going to be worse than Okay? Process elimination?
No. Mr. Hodges, I have to do the oil, okay?
Yeah, cool. Good job.
So,
So go ahead and fill your jar about halfway with water, okay?
let's read it in.
Elijah, are you done?
So let's
Are you done? Could you fill this up, fill this jar up to about halfway with water? Okay, that's all right. We're gonna get, let's see.
determine its temperature.
Amelia, you're done, right? Can you fill up your jar about halfway with water?
Halfway?
About halfway like that. Okay?
That's why we say water turns into a gas. Or maybe like say jello, right?
And Ginger, are you still working or are you done?
Done? Can you fill up your jar about halfway with water?
Number 1.
I have a water jar now.
I made it from this.
Okay, guys, make sure you're,
If you guys have Chromebooks out, make sure they're somewhere that they're not gonna get.
Put your Chromebooks
Any liquid on it,
in
okay?
the Chromebook cart. Quick, don't have to charge it just yet, just put them in there.
I'm just gonna.
Not saying it can overflow, but I've seen people
Put them in
make
the
it
desk.
up.
Just
Put it on there.
get water on it. And guys, it doesn't have to be in order, just put them in for right now, we're not charging them. I'll have you fix that later.
Guys, no, not be throwing. Let's go.
Shh.
All right, help your team out if they are still working. Okay. Who here still needs a little more time? Okay, keep going.
All right, let's read the first question. In your own words, what is density?
The next thing we will do is we will add food coloring to this. So I'll go down to the tables now and add food coloring, okay? All right, for food coloring, actually we'll do it afterwards. What color do you guys want? We have to mix, we can mix, we'll have to mix it. Okay. I also have pink. Everyone's, okay. We're gonna figure it out. All right, stop it. Okay, so what do you think's gonna happen if I add oil to this water?
It will go to the top.
It will not mix, right?
Yeah,
So kind of Elijah, it will stay on the top.
it will take you.
So just kind of watch, guys. Me and Mr. Roger gonna do this.
Gee. Whoa. Gee, it's not like I drew that.
It's still going, right?
Yep.
Still going. Yeah, we have to add a lot.
It's gonna cap right at the top.
That's good. Look at it right away, right? We can already see the layer. See? Here's the layer. So there's already a huge layer to that. Okay? So what do you guys think is going to happen if I add the food coloring?
It's not gonna mix. It's not gonna mix.
It's okay. So how many of you believe it's not going to mix? Okay? What do you think is going to happen though when I add it? Do you think it's going to go down or do you think it's going to get stuck? What do you think, Bentley?
It's gonna stay up.
It's going to stay up? What do you think, Carly?
Stuck.
Stuck? What do you think?
Stuck.
Stuck? It's not check. Okay, who else? Does anybody else think it's going to be different?
I think it might turn the oil
Might turn the oil?
over.
What do you think, Sophia? What do you think is going to happen?
So you think it's gonna color the water?
Do you think it's going to color the water? Does anybody think anything different? What do you think, Anthony?
I think the chemicals. I think the chemicals inside of the food coloring will push down all of the oil.
You think it's going to push down the oil? Okay. Let's see, Nathan, you had your hand up. What do you think is going to happen? No? All right. So, guys, watch what happens when I add the food coloring. I'm going to lift it up here. There it is.
Oh, right, that. Oh.
Oh.
It's going through. I forgot about that. It was like
Mine
it's getting stuck. It's staying.
It's slowly going down.
That was kind
It's slowly going to go down.
We were kind of right.
It's all right.
It did get
So it's going to get stuck, but it will go down.
It's not gonna mix. Oh, I see it. It's going down.
It's going down little by little.
Let's go.
Okay? So we're going to add, since this is a big jar, we can add as much food coloring as we want here.
The whole. I told you.
It's not going to mix, right?
Yes.
It's not going to mix. And eventually, yes, it will go down. It's slowly going to go down. It's slowly going through. So it's already going through. So the next thing we are going to do, I got to show the camera just to kind of show them what I did. But okay, what did you guys want?
Red.
Red.
No,
Oh, everybody.
Blue.
Put as much as you want. Okay, you wanted blue, right? If you guys want 3 colors, I'll give you guys 3 colors.
What do you want?
Yeah, do we have 3 colors?
Look at it right away. You see the drops?
We have orange.
Focus on this. Look what's going on. Look at this.
We said we can have 3 colors.
No, because if you come home with the big old red mess all over you, guess who's responsible?
No, we won't come home with it. You're like, oh, it's really cool.
It's still going down.
I told you already.
Okay, so Wilson, you want me to stop there? You want more, guys?
Do we have different colors too?
I think something's
If we do that, this whole
It just made it raspberry.
Red? They have red. I have pink.
red.
Oh, that one's red.
We got blue, orange, pink.
Guys, share it along carefully. Hold it carefully, pass it, show it.
There's a shield around the
Here's what I know why it's has a bubble. It kind of makes the wheel so it's just like sitting.
So just so you guys see my jar, look at it, it's already going like way down like that. Slowly going down. Okay, there is yellow up here. If you guys want yellow, you can add more colors to yours if you want. If you make yours green, I can put yellow. You want yellow in there?
Yeah. Wait, did that go up?
Oh, look at that. You can pull some of the.
You guys want yellow? Then yellow. Be careful, don't get it on your hands, because Mr. Reese's thumb looks like he just beat up a Smurf.
From the top.
Yeah, I told them I don't want parents to go and see red all over them. One drop. Each of you.
Look. Just turn it this way.
It does look like I have it.
Just look at from the side.
Elijah, sit down. Relax. Okay, so the next thing we're going to do is we're going to add a chemical reaction, guys. So we are going to add Alka-Seltzer. From the reading, what does Alka-Seltzer do, guys? What does it have? Santiago,
It has a chemical reaction and it starts fizzing.
what chemical is in there? They mention it in the thing. Family, what is it?
So
It's up on the board.
what chemical they have in it is like it fizzes and it's like carbon dioxide.
There it is, carbon dioxide.
You break the
So this is what we're going to do. Let's see what happens when I add this in there.
Oh my!
Come on, Chris. Let me take a picture of you, girl.
I know, that's slime. Look at the color.
Oh,
That's what I said.
Watch the oil, watch the oil.
We keep these.
We'll see, guys.
Look at ours is doing.
Mm-hmm.
It's up here. It went up.
your finger in there pointing, Santiago.
That's what's happening.
So, one more?
15. Can we have one more to drop it in? My drop one better.
Oh,
Yay.
You mind if I, pass?
Yeah, of course. I figured you guys are gonna want to see this more than once, so go ahead.
Just has one. Mr. Hodges has it for you guys.
And Hodges, because it won't come up here. It's the only one.
Guys say, don't drop the finger.
You're too late.
You guys just drop one in?
One more.
So, what would happen if you guys drop a little bit? Straight up? Sorry, that's what we're gonna do.
guys,
Oh,
let's see what happens.
See what happens? Drop the each in, guys.
Drop it in. What, you want to see it?
Very wise, very wise.
Here, wait. You just killed my sister.
Wash your hands because it will get all everywhere. Okay?
All right, so now that you guys have seen it, the first page. There's 3 more questions. Fill those out, please.
Class? Class? Isn't this an awesome experiment? You have now, Mr. Chris just told you what you need to do next. Did anyone hear what he said? Orion, can you repeat to the class?
He said on the first page, do the questions that we couldn't do at first.
So go ahead and get those done for me, guys.
I got a little bit of blue in my hand.
It's all right.
I told you not to go messing with Smurfs. They're tough.
Well, I'm not.
And guys, I told Mr. Hodges some other experiments I know of we can do, so maybe we can work on getting those too, okay?
But I wasn't too enthusiastic, Carly. You're right. Yep.
This is like science.
It is science. We learned the density between liquids. We saw the weight difference.
Those are called Celsius. Yeah, we call it Alka-Seltzer.
Can I just say something? What are they originally for?
Normally they use them
It's
for like
just
bowls.
Alka-Seltzer water.
Alka-Seltzer.
Alka-Seltzer helps with the upset stomach. So that's mainly what it's for. Okay, then once you guys are done, go ahead and whoever that's done for you.
What is CO2?
CO2 is the carbon dioxide.
I thought something broke.
I'm gonna let those settle because if I put a lid on it, it's probably not good.
You should put a lid on it and flip it over.
So let me ask you. So that's something that will. Let me ask you.
What would happen if I flipped it over? What do you guys think?
It would bubble again.
You think it'll bubble again?
No, it would go up. All the bubbles would go up. Show up.
Class, let's see. So here's what's gonna happen, guys. But it's gonna take too long. If I was to mix this together, it would all mix together, but eventually, slowly, it'd separate itself just like this again. It takes a long time, but I've done it before. So I shook the whole thing and it mixed together, and then it slowly started separating. So it looks just like that again, because oil and water don't
So if you
mix.
shake it, that will be good.
Yep, it'll separate after a while. Takes some time. But like for yours guys is still bubbling, so it's probably not a good idea to seal it. So, right? Yes. You don't have to. There are other ways to do it without Alka-Seltzer, without the carbon dioxide, but it doesn't do this kind of reaction.
If you mind me adding just real quick too, Chris. So guys, if you think about lava labs, who here owns a lava lab or has owned a lava lab? Okay, and that's okay if they broke in, Britt. I just want to know who owns a lava lab. All right, guys. So let me ask you this: how was a lava lab? This lava lab experiment, what did we use to get the chemical reaction? Okay. Good. So let me ask you this: how do lava lamps then, using density, how are we able to use or how is the liquid, the lava, able to move inside the lamp? Turn to your neighbors and talk to them.
Density.